Namaste everyone. Welcome you all to Sadvidya Academy Physics classes by Ganesh Habbar. Today's topic is Class 11 Physics, Chapter number 1, Units and Measurements, Part 7, Applications of Dimensional Analysis. In today's topic, we shall discuss about the applications of dimensional analysis. In that, first one is applications means uses. First one which we are going to discuss is checking the dimensional consistency of any equation. If any equation is given, how to check whether that equation is dimensionally true or not by applying the using the applications of dimensional analysis that we are going to study. The first one, it is the checking the correctness of an equation by using dimension analysis. The given equation is S is equal to ut plus half at square. It is a very important equation which we have studied in motion in a straight line. So any equation might be given in your board exams. So when that equation is given, what you need to do is you need to write. So the question will be asked like this: check the correctness of the equation S equal to ut plus half at square by the method of dimensional analysis. That will be asked. Next, what you need to write? There is a principle called as the principle of homogeneity of dimension. What does it say? According to the principle of homogeneity of dimensions, an equation is said to be dimensionally correct if dimensions of each part of the equation are same. What is the meaning of that? ಯಾವಾಗ ಒಂದು ಈಕ್ವೇಶನ್ ಅನ್ನ ಡೈಮೆನ್ಷನಲಿ ಟ್ರೂ ಅಂತ ಕರಿತೀವಿ, ಯಾವಾಗ ಅಂತ ಹೇಳಿದ್ರೆ ದ ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ ಈಚ್ ಪಾರ್ಟ್, ಪ್ರತಿಯೊಂದು ಆ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಪ್ರತಿಯೊಂದು ಪಾರ್ಟ್ ನ ಡೈಮೆನ್ಷನ್ಗಳು ಸೇಮ್ ಆಗಿರಬೇಕು. ಹಾಗಂತಾದ್ರೆ ಮಾತ್ರ ನಾವು ಆ ಈಕ್ವೇಶನ್ ನ ಡೈಮೆನ್ಷನಲಿ ಕರೆಕ್ಟ್ ಅಂತ ಕರಿತೀವಿ. So say for example, what is the meaning of that? In the given equation, say dimensions we have studied already. What are dimensions? These are nothing but the powers to which the basic physical quantities must be raised to get that particular physical quantity. So according to this, it is actually common sense. That is nothing but it says that you cannot add kg plus meter. Is it meaningful if you add kg and meter? If you consider there is one term that is in an equation, there is one term whose dimension is kg and one more term whose dimension is meter. One is of mass and one more is of length. Then can you add that two quantities? No, it is not possible. Then such an equation having mass plus length, it is not possible to add. So that equation is wrong, we can directly say. So according to the principle of homogeneity of dimension, what does it say? You can add any two quantities only when the dimensions of both the physical quantities are same. That means you can add either meter plus meter or length plus length, that is nothing but meter plus meter, or kg mass plus one more mass you cannot add, but you cannot add mass plus time. Is it not? Or you cannot add velocity plus acceleration. You have to add velocity plus velocity. That means if there is a plus sign in between or equation sign in between, then each part of that equation must have the same physical quantities. That is the meaning of this particular principle of homogeneity of dimension. So in order to prove whether this equation is right, what you need to do is you have to write the dimensions of each part of the equation. Which are the different parts? One is S, that is the displacement, and one more is ut, and one more is half into at square. Here half is nothing but it is a constant. It is a dimensionless physical quantity. No need to write the dimensions of that. It has no dimension. So we shall write the dimensions of each part. So what are the dimensions of S? It is nothing but displacement. Am I right? So it is displacement. Displacement is nothing but inside the square bracket m0 L1, that is length. Displacement is nothing but length to the power 1, and t0, That is the dimension of first part of the equation. And second part, what is the equation? U. U is nothing but the initial velocity. What is the dimension of velocity? That is m0, L1, t minus 1 is the dimension of u. Into t will be there. T is nothing but the time. So m0, L0, t1 is the dimension of the u and t. Now multiply this. What you will get when multiplying? That is, multiply this m to the power 0 into m to the power 0. It is m to the power 0 only. L to the power 1 into L to the power 0. That is L to the power 1 only. And t to the power minus 1 into t to the power 1. So minus 1, that is divided by t. This is plus 1 into t. So divided by t into t is 0, t to the power 0. You got the u into t, you got this dimension m0, L1, t0, and half a t square. No need to write the dimension of half. You write a. A is nothing but acceleration. That is, its dimension is m0, L1, t minus 2. That is the dimensional formula of acceleration into t square. What is t square? It is m0, L0, t is t it is. So t can be written as time whole square. When you multiply it, this and this, that is multiplication. You have a into t square. It is a, it is t square. So when you multiply, what you will get? You will get this particular term. We shall multiply m to the power 0 into m to the power 0 whole square. That is m to the power 0 only. And L to the power 1, L to the power 0 into 2. That is 0 only. L to the power half into a. A is L1 t to the power minus 2. So into L1. So L1 L to the power 0. So totally it is L1. Is it not? L1 into this L1 into L to the power 0 square. That is L1 only. So t to the power, it is minus 2 here, but here it is 1 whole square. That is minus 2 plus 2. Minus 2 here and plus 2 here. So totally t to the power 0. Now you have written the dimensions of each part. Just write it in terms of equation sign. S equal to ut plus half a t square. Yes, S is nothing but m to the power 0, L to the power 1, t to the power 0, which is equal to half a t square. That is the ut. What is the dimension of ut? This is the dimension of ut. That is m to the power 0, L to the power 1, t to the power 0, plus half a t square. What is the dimension of half a t square? M to the power 0, L to the power 1. This is the dimension, right? So m to the power 0, L to the power 1 and t to the power 0. This one. Am I right? Alva. So this I can write like this. Now look at the dimensions of each part. This m0 L1 t0, m0 L1 t0, m0 L1 t0. Hence dimensions of each part in the above equation, dimensions of each part of the equation are same. Therefore the given equation is dimensionally correct. That you need to write, dimensionally correct. If suppose if a wrong equation is given, then you won't get the same dimensions in each part of the equation. At that time you need not supposed to write dimensions of each part of the equation are same. Here it is same, but if they are different, hence the given equation is dimensionally incorrect. You have to write. Here it is correct, I have written it as correct. That is one of the applications of dimensional analysis. Now here we shall discuss on one more application of dimensional analysis. What is that? It is a deriving relation between different physical quantities. So how to derive the relation among different physical quantities? That we shall see. For taking it as an example, we shall take the time period of simple pendulum. So while performing the experiments on simple pendulum in the lab, we have taken a simple pendulum of length L and the mass of the bob, let it be m. Is it not? So mass of the bob, let it be m. Now, while performing the experiment, we have come to know that that time period of that pendulum, time period t, is dependent on the length of the pendulum, because when we decrease the length the time period changes, when we increase the length also time period changes. Say that must depend on the length then. So we shall see. And one more, we may assume that when we take a bob of larger mass, the time period may reduce. That is why we might also assume that the time period also depends on the mass of the bomb. And of course, the third one, that is the acceleration due to gravity, it must depend on. So that is why we know the factors or the quantities on which the time period depends on. Which are all the quantities? It depends on length L, mass m, and the acceleration due to gravity. We shall write the equation for that time period. Then I can write it as time period t is proportional to L, also proportional to m, and also proportional to g. But we don't know whether it is directly or inversely proportional. That is why we shall take the values of x, y, and z as the powers of L, m, and g. Why? Because when we get the value of x, y, and z, at that time we'll come to know whether it is directly proportional, whether it is proportional to square, whether it is proportional to square root. All that values we will come to know. So now, how to derive the formula for t using dimension analysis? So that is a method. So what we shall do is, we shall write the dimensional formula of each term of this relation, that is proportionality equation. So we shall write, what is capital T? It is nothing but the time period. So what are the dimensions of time period? It is m to the power 0, L to the power 0, and t to the power 1. Is it not? So which is directly proportional to L to the power x. What is L? L is nothing but the length. So m to the power 0, L to the power 1. Why? Because it is nothing but this is nothing but the length. L to the power 1 and t to the power 0 whole to the power x. And into m. What is m? M is the mass. So m to the power 1, L to the power 0, and t to the power 0 whole to the power y. And one more, that is g. G is nothing but acceleration due to gravity. What is the dimensional formula of acceleration due to gravity? It is same as acceleration, m to the power 0, L to the power 1, t to the power minus 2 whole to the power, we have taken z. Now how to obtain the values of x, y, and z? Since this equation is a proportionality equation, the powers of m, l, and t must be same on both the sides of the equation. So we shall equate the powers of m first, equating powers of m on LHS as well as RHS. So what is the power of m on LHS? It is 0 is equal to right hand side, m to the power 0 whole to the power x, it is 0, plus m to the power 1 whole to the power y, that is m to the power 1 into y, that is y, plus here m to the power 0 in whole to the power z, 0 into z, that is 0. So we end up getting what? Y is equal to what? 0. We got the value of y. Similarly, we shall equate the powers of, equating powers of what? Equating powers of L We shall equate the powers of L. What is the power of L on left hand side? It is 0. 0 is equal to L to the power 1 whole to the power x, that is 1 into x, that is x, plus again m to the power 1 L to the power 0 into y. 0 into y is 0, plus here third one L to the power 1 whole to the power z, that is 1 into z, that is z. So from this equation what we get? We get an equation x plus z is equal to 0. That is a one more equation which we get. We shall take it as equation 1. Okay, next now we shall equate the powers of, equating the powers of which one? Powers of t, powers of time. At that time what we end up getting? Here L to the power 1, so 1 is equal to, here t to the power 0 into x, it is 0 only, plus t to the power 0 into y, it is 0 only, but here at the end, here it is t to the power minus 2 whole to the power z. That means I can write minus 2z. So I can write what is the value of z we will come across. From this equation we can write, what you will get? Z is equal to minus 1 by 2. Is it not? So we got the value of z. Substituting this value of z in equation 1. So equation 1 implies x minus half is equal to 0 or x equal to plus half. So we get the values of x, x is here, y is here and z is here. Substitute the values of x, y and z in, let us take this as equation star, this one. So in star what you will end up getting, that is t is proportional to L to the power x. What is the value of x? X is half, L to the power plus half into m to the power y. M to the power y, what is the value of y? Y is 0, very interesting, m to the power 0. That means it is independent of mass. M to the power 0 is 1. So it does not depend on mass anta gottaito. And L, M and one more is g to the power z. What is the value of z? It is minus half. Now if you combine, what is the meaning of something to the power half? That means it is under square root. So what you can write it as, t is proportional to square root of it. Here it is minus half, here it is plus half. Minus half is means it is in the denominator. That means I can write L divided by G. Or how to remove this proportionality sign? T is proportional to root of L by G, or T is equal to some constant K, constant of proportionality into root of L by G. This is a formula for the time period of a simple pendulum. By experiments, what we will get? By experimentation, the value of k is found to be equal to 2 pi. So we end up getting t is equal to 2 pi into square root of L by G. By looking at this particular formula, we see that t is independent of the mass of the pendulum. Remember, it is not dependent on mass of the pendulum. Mass na mele time period depend ಆಗಿರೋದಿಲ್ಲ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. Therefore, the formula for the time period of a pendulum is t is equal to 2 pi into root of L by G. That is a formula which we have derived by using the method of dimensional analysis. The last concept in this particular chapter which we are going to discuss is about the limitations of dimensional analysis. What are the drawbacks or what are the limitations of dimensional analysis that we are going to discuss in this particular concept. What are the limitations? First limitation is the value of dimensionless constant cannot be found by the method of dimensions. That is nothing but just now in the previous the application of dimensional analysis, we have derived the formula for the time period time t equal to 2 pi into square root of L by G. This value of 2 pi cannot be found out by using the method of dimensional analysis. This has to be found by experiments only. That is why, because 2 pi has no dimensions, it is just a constant. So the value of 2 pi that cannot be found, or the value of any dimensionless physical quantities cannot be found out by the method of dimensional analysis. That is the first drawback of this particular value, this particular dimensional analysis. Drawback of dimensional analysis. Second drawback is it can only test the dimensional validity but not the actual relationship between different physical quantities. That means it says whether that equation is dimensionally correct or not. Dimensionally correct wrong ಅಂತ ಹೇಳುತ್ತೆ, but it cannot say whether it is actually true or not. Say for example, if I write v square equal to u square plus 2as, where v square is the final velocity, u square is the initial velocity square plus 2as. But instead if I write u square equal to v square plus 2as, instead if I write v square plus 2as, it according to the dimensional analysis, it says that it is dimensionally right. But whether it is actually right, no, that cannot be predicted by the method of dimensional analysis. That is the second drawback of dimensional analysis. And what is the third drawback of dimensional analysis? It does not distinguish between the physical quantities having same dimension. Say for example, there are many physical quantities having same dimensions. Say for example, work and energy has the same dimension. It will not distinguish between the two. And say the time and the time period, capital T and the time, so both are having the same dimension. It will not distinguish between any two physical quantities having the same dimension. Speed and velocity both has the same dimension, but it will not distinguish between any two physical quantity. These are the different limitations or some of the limitations of dimensional analysis. Thank you all.